And we're back. Same bullshit as last time. Where did I leave off? We had this blob store thing with the circular array of metadata, and yeah, it's not going to compile yet, but it's not even done yet. It's not even fully coded. So let's see what else we can do here. Let's just go through the file real quick. Reserve means that we basically, oh, also by the way, I figured out address holder. What we really want is, shit. We're gonna get passed in an index to, we want the address of the address. So when we call it, bunch of params, and we're going to take the address of some pointer, and then we're going to do pointer. Okay, this pointer will then be set to the actual data, the actual spot in memory, memory spot, and you can write it like pointer 0 is equal to 42 or something. So I believe this needs to be a void star star. So it's a pointer to a pointer. And if we modify a pointer to a pointer, then the original pointer will do something. Now, alternative option is to return the address and modify a passed in int 32 for the ID. So for the ID. Okay, but anyways, let's just fill in some of these. So if bs start is equal to bs md end, I really should have jotted this down, but before I forget, it's going to be bs md start is metadata start. In the case that the metadata is empty, it will be -1. Then it will what the fuck? Why do I have an alarm set? That's weird. Anyways, then it will go up to 0 and increment as we free blocks. Okay, md end is the index of the next metadata slot. We will write to it before incrementing. Okay. So what can we do here? If bs star is equal to bs md star is equal to bs md end, that means that we have what? We want to reserve a new block, but we've currently reserved all blocks and we've looped back around. This could be the case. This is the case where all blocks are reserved. So the whole thing is full. So all we need to do is double, and this is for the. I think this is the more complicated one because we also need to. Oh no, it's not. It's not. Never mind. Do we need to double the capacity? Not necessarily. Not necessarily. We might not have to, but let's go ahead and double the metadata anyways. All we need to do is bs md start. So it doesn't matter if md start is like 5 or 6. So if it's 5, it's going to go from 5 to capacity, then to 0, then to 5. That doesn't matter. We can just pretend that we can just shift it because it's all continuous anyways. So MD start will now just be 0. MD end will be, I guess, 1. Oh wait, yeah. So right now, if we don't double it and we write, we're gonna write the next block, the next metadata block into the index of the start. So we can't do that. But what we do want to do is write the next block into one past the end, and that is gonna be, I believe, just capacity. So we're gonna do that before we double. Critically before we double. So right now, if we try to write, it's not gonna work because it's kind of out of bounds on the metadata array. Current, let me just jot that down. Meta is out of bounds on metadata array. Okay, so now we actually need to double it, copy it over, and we're good. I wonder, let's see, double. Okay, well, the double is easy. We just do BS or BSM star doubled is equal to malloc capacity. Let's double capacity, since we gotta do that anyways. Capacity is equal to BS capacity. Oh, well, we need to copy it. Fuck it. We'll do that after. Times 2. Or, no, I'm not gonna assign a new variable. Okay, BSM doubled star is equal to malloc. We're gonna do capacity 2 times capacity times size of BSM struct. Okay, so that's doubled, the new array. New array. And then what we do, new metadata array. Not the store, we have two at play here, metadata array. If it's doubled, then we need to copy, which I don't know how to do, but the last thing we do is free BS metadata. So that block is gone, and then BS metadata is equal to doubled. And then double capacity at some point, we'll see. And then we do not return, we can actually do this. Free old one, use new one. And none of this is tested at all. Not even close. Okay, so now, okay, the naive way to do this, I believe we just do for, what is capacity? Capacity is a UINT. Let me pull up that header. Oh, we don't even have it. Maybe it's a UINT 32 type. I is equal to 0, I is less than capacity, I plus plus, and then we just do doubled I is equal to BS metadata I, something like that. Is this gonna work? I have no idea. I have no idea. We could test this by setting capacity to be very low. But actually, let me see if there's a more efficient way to do this. No idea if this is the right way. Because what are we doing here exactly? BS metadata, this is a struct, and we assign it to that. Oh, is it, do we need to do, oh no, that's the, okay, let me just do this. How to copy an array, C. Not skip the, here we go. Yeah, this is exactly what I need. Since the memory size, if you can't, you can simply copy the memory block from one pointer to another. Mem copy. Okay, mem copy. All right, let's see if we can find this in the in this guy. Mem copy. No, perfect. Mem copy GNU. Cool. How do we do this? Wait. Wait. Here? Okay. Okay, that's super useful, dude. That is super useful. Oh wait, no it is. Copy n bytes from the object pointed y. Oh, this is a system call, isn't it? What is it? What do we need to include it? What do we need to include to get it? Is memcopy the best option? Much faster than mcopy. What is this? Your pointer swap code, you're dereferencing your point. What does this do? Okay, there's a double array. What the fuck is this? Oh, okay. That's kind of weird. Oh, if you just want to swap the pointers is easy, but we do need an actual memory copy, I believe. Because if you just think about how memory works, you can't just extend it past a reserved block. Might not work. Shall copy and bytes from the object pointed to by SO into the object pointed to by S1. If copying takes place between objects that overlap, the behavior is undefined. All right. Let's see if this works. And returns a void star. Of course it does. I guess we could just do mem copy. Wait. Why do I need string for this? Wait, no way. This is not. Wait, functions in string. Wait. Oh, okay. Okay, it makes. I see why you need string, but it's just. I thought it would be, somewhere else. I mean, this seems like a very important method. All right, mem copy. We're gonna copy. Let me give you an example. Copy. If the copy is really needed, let me just add a note. Do we need to copy? I don't know. I mean, this is rare. This is a rare event, and we can actually, if we run the simulation a few times, we can just choose an initial capacity that's good enough that we never need to double. But this is how you build robust systems. Actually, that would be a little bit faster because you get rid of this. You don't have to run this line. We could probably do some like end define stuff later, but whatever. Array new is going to be doubled. The old array is going to be just the regular one, which is BS metadata, and the number is just BS capacity. Sorry, no, MD capacity, not just capacity. Capacity is not quite it. Just toss that one in there. MD capacity, okay. And then we can double it. Cool. Well, we have to, oh well. Okay, I think this is good. Okay. Looks good, looks good. Of course it's in string, why wouldn't it be? Okay, so this is cool. We have this metadata array. Meta capacity. So now at this point, as of this line, the metadata is big enough, but maybe not something else. So let's see. If we have 0, what is this? So this is in the rare case that we're in the initial state, so we don't have anything. MD start makes kind of sense to put at -1. MD end is still 0 because that's where we need to write. And in fact, I think we might even be able to get away with something like this. Skip an extra comparison there. All right, now double until it fits. Yeah, double until it fits. So we might need to do more than just, let's say, return, eh? Yes, but we do also need to modify this. We need to do the value at address holder is equal to the address of BS store zero. Which I suspect might be simplified as just this, but I don't know. Maybe. Because it's a kind of a special case, we'll just set it to BS store. Okay, so that'll assign the address holder, and this is a special case where we only have one. Maybe we can fold it into one of these, but I'm not sure. Maybe we should keep it as a special case. All right, next one. Double until it fits. So what we actually need to do here, let's say we have a tiny capacity and we need to reserve like a gigabyte. We don't just want to double it a bunch of times. We want to find exactly what value we want. So to do that, what we can do is we're going to set it to the next greatest power of 2, which I think there's got to be an easy way to do this. It's got to be like a super efficient way to do this in like bit operations. We don't need to copy, just free and malloc. Yes, we don't need to copy at all. So that was an easy one. So we can just do free BS metadata. And since we don't copy, we can just directly do BS store. Store is equal to malloc something times size of BSM. No. What the fuck are we gonna put in here? Is it just this maybe? Size must be in bytes. Let me jot that down. This is like a size must be in bytes. Let's go here. All right. Yeah, so it's just going to be some number. Now the question is UINT32 type. If it's more than 4 gigabytes, we have a problem. New store capacity is equal to basically size. Basically, this is how I would do it in JavaScript. There, like that. And we just pass in new store capacity. Now, if I know anything about integers, I know that we don't actually need that floor. And 2 to the power of something is going to be equivalent to whatever, or 1. Is that right? Let me test this out. Here, what does this do? Perform a left shift operation on the left operand, shifting by the number of bits, not the other one. So it appends a 0. Okay, perfect, exactly what I need. So we just need one bit shifted math.log2 size. Basically, this is basically what we need. Oh, math.log size plus 1, which actually we can just hard code that as 2. So something like this. The question is, does this even work in Node as I expect? So if we do math.log 2, 2, 1, 3, okay, 4, okay. Okay, that's what I expect. If we need like 4 billion, 31, floor that, and then plus 1, that's 32 bits, which sounds right. So this is correct. What can we do? Oh, perfect. Okay, so if we do 2, that. Oh, because it's 32 bits. Okay, let's say what's a good example? 65500, which is about 16. Yeah, perfect. Okay. Now, how do we get the natural log in C? Is there a single maybe I'm overthinking this, but is there like a single operation that we can do? Because I don't want to just shift it until it's equal to 1. That's one option, but I don't like it. Okay, let me just look this up. Log 2 in C. Oh, wait, seriously? Just like that, huh? What does it do? How does it work? What is it included in math.h? Okay. How is this implemented? Double. No, I need an int. Integer. Ooh, wait, BSR. Answered in 2009. Oh. Bit width. Bit width. What is this? I've never heard of this. What is, oh, this is C++. Damn it. Oh, this is AI, hold on. Sorry, mate. Actually, I'm not sorry. I know it's a bit weird, but I like this integer. This answer was interesting. BSR. All right. Well, this is rare. This is very rare. This is the case that the very first one, because this thing is almost never going to be empty, so I'm definitely overthinking this. Let's just use the while loop option. Size, let's just do uint32 type. Copy size is equal to size. We'll do uint32 type. Oh wait, no, even better. 2, and then we'll just do while copy size is less than size, or there, 2, while new store new store capacity is less than size. If it's equal, if it's equal, that's, it's iffy, but it's fine. Yeah, no, we definitely, whatever. Okay, new store capacity, shift 1. Or could we just do, we could just directly use new store capacity, we can just do this. There. I don't even need a new variable. So we will double until it fits, actually. Okay, then we do that. We do, we remalloc store capacity. Cool, it's done. All right, so now we definitely have space. We can just put at 0, BS start, we update address holder, and that looks good. Okay, cool. Now let's take a look at a more interesting case, which is, okay, if first is less than last, wait, what the fuck is it? Okay, if first is greater than last, so we kind of have the case where we looped around, and then the end is approaching. We just looped around. So start capacity back to 0, then end. What do we need to do here? What does this mean? There's not enough room between first and last, is what I'm hearing. Okay, here's what we do. We need double encode, double capacity, make an array at the new capacity, take a blob from start to last, copy it to the array, and metadata free all data. Okay, so if we don't have room, and it's kind of looped around, here's what we do. Free old array, that one's an easy one. That one's just going to be free BS store. We do need to update the metadata table. Yeah. Well, let's make a new one first. So we'll do, we can copy some of the double encode. Okay, I guess this is a void star, double, yeah, doubled is equal, oh, should this be like a type, like parameterized, like T? Maybe. I have no idea. That's only a thing in C++. Anyways, void star doubled is going to be malloc. Actually, we can double capacity right now, I think. So BS meta, no, store capacity is equal to BS store capacity to, there. Okay, so malloc BS store capacity, the new one. Okay, so we have it, we double capacity, we make it array at the new capacity, then we take each blob from start to last and we kind of redo it. All right, so for we need like a run variable. So for let, not let, uint 32 type, I is equal to first, I is less than last. Wait, no. Wait, that's not quite it. It's actually MD start, BS MD start, and I guess it's gonna be more like a not equals type of situation, because if we do less than, then we immediately finish, because the start is after the finish. So as long as it's not equal to the last, so this will definitely need to be tested as well too, but last I is not equal to what exactly? last MD index. So we're going to loop around until that. So then I is going to be, we're going to do this thing. So I is equal to I plus 1 BS MD capacity. So this will iterate properly through the whole through all the wait. Yeah, this should iterate properly through all the metadata. Now, just because we reshift the whole store doesn't mean we need to reshift the metadata array, but what we're going to do is just rewrite everything. So we're gonna let's what do we need to do? We need double encode. Yes, we do. Take each blob from start to last. That's what the for loop is doing. Copy it to the new array and update offset in the metadata. So the offset is going to be for the old array we're already doing. Try again, check between end and capacity. I might just call the method again. That might be easier than like rewriting this whole fucking thing. Oh wait, no, it's going to be a simpler case. Oh well, let's just see what we need to do. So copy it to the new array. So we can use mem copy again. We're going to do into, we need the exact address, don't we? Where was it? Here. I don't think it actually matters, like the offset. We need to object pointed to by S1. So we're going to copy into, I think what we need to do is something like doubled BS metadata. We need some kind of like running count of like where we are. So uint32 type 0 current start is equal to 0. Current start. So we'll get the address of that. And this is what it's going to be copied into. And then we're going to copy from BS store BS BS metadata I. Start. Yeah. So this is what we're going to copy from. Right there. And how much are we going to copy? It's going to be very similar to this last thing. BS store, except we're going to copy amount of size. And it's not going to be start, is it? It's called offset. Call that offset. Cool. And that looks pretty good. We have memory copy. Okay, so we have a memory copy, and we also need to update the actual metadata store. So the only thing we really need to change is, we don't need to change refs, but we do need to change offset. So this is going to look like BS metadata offset is equal to current start. And then we can bump current start is equal current start plus size. So this is where the next one's gonna go. Okay, and this hopefully does not break. And if this has to fit, because if it fit in the previous one, then wait. Actually, I just thought of something. If we go to the end, we might not necessarily, it's pretty likely that we're not gonna, oh God. No, I think this is right actually. Even if we go past the end, we're reading from the offset, which is already handled. And we shouldn't go past the next offset because we doubled the capacity. So I think this is good. All right, cool. And then we try again, we don't return. To do that, what do we do? We FreeBS store, and we can try again, check between end and capacity. We can't even assume, like if we just insert a really big snapshot, we need to like maybe more than double, maybe we need a quadruple. It might just be best to just call this again, honestly. So return BS reserve BS, which is, it's a rare scenario, but BS reserve, what do we have? BS, just copy the signature real quick. Drop the types. Yeah. This is an easier way to do it. But it's wrong because we're actually because the metadata is already going to be created. We just forgot to insert it. Okay, fuck. Never mind. Not simple to just recurse, as we have already created metadata. Or have we? Oh no, wait, we haven't. This is the beginning case. And this is the doubled case. This handles metadata. Also, no. Actually, I think we can recurse. Where's recurse? Yeah, I think we can just call this again. So what'll happen is we'll rehash the entire store in this doubling code, and then we're not going to have this case anymore. We're actually going to have this case. So where first.offset is less than last.offset, because first is now 0, last is last, so it's continuous. It doesn't loop around, so we can just put it at the end. And we're probably going to hit this case, which we need to fill out too. But otherwise, everything looks pretty good. So let's try this. So first offset, last offset, etc., etc., etc. I think we can copy this whole thing. Okay, let's look at this, for example. Oh wait, no, this one's more simple. We don't need to. We can copy the entire store array into the new capacity. We don't need to do this thing. We can actually keep the offsets as they were, because it wraps around. Oh, but only in the Well, let me think about this. Let's think about this. Okay, what's going on here? So if first is less than last.offset, that means that there is, we have this array. Here's first, here's last. So they're continuous, and they haven't looped around yet, or maybe they looped around and went through. But anyways, we're in this kind of case. And then we don't have space we don't have space between the end and the capacity, and we don't have space before the first. Now it's possible that if we just shift it, we will have room without even doubling the capacity. Let me jot that down. It's possible that if we just shift everything, shift it such that start offset is at 0, we can fit another block in. So if we do this, we might be able to just fit it at the end, but maybe not. I think it would be easier, and again, this is kind of a, I guess, a rare scenario if we size the capacity correctly at first. So I'm just going to go with the simpler case of we take the whole thing, the whole store, and we just copy it into a doubly sized one, which is going to look like this. We'll double it later, actually. Store capacity is equal to BS store capacity 1. But we'll do the easier case and just copy everything without modifying the metadata at all. So we'll do that later. Make a new array at the new capacity. So void star doubled is equal to malloc bs. I know we should probably put this in a helper function, but I need to just get us all out first. Malloc bs store capacity 2 times that. Okay. Then we can do, we have that doubled array. All we need to do is mem copy into doubled from store. So the whole thing. So there. So double capacity, take each blob, copy to the new array, free old array, and then finally there. Do we try again? Yes, and we're gonna hit the same case, and hopefully this doesn't happen anymore. Or no, wait a minute. We don't have room. We don't have. Actually, it's most likely that we're gonna hit this case if we try again. But let's just go ahead and try again anyways. We haven't created any metadata yet, so this is fine. Okay, so this when we hit this case, it'll actually when we call this, it'll go into this one. When we hit this, most likely it'll go into this one. It might go into this one again if we need to, if it's so big that there's still not room after the end and there's not room after the beginning. We're definitely not gonna hit this case because we didn't change how much room there is before the first one. Okay. We'll just do the easier. We'll do the easier thing and just copy everything without modifying the metadata at all. All right, cool. Try again. Check between end and capacity. Put it after last. I think this might be everything we need. Let's see how many errors we get. Oh wait, no, we still need this one. We need to do this one properly. Get BS, all snapshots freed, nothing managed. Anything else I need to do? I have no idea, but something like this. Yeah, I have no idea either. FL, why do we have FL here? We don't need FL, hold on. We don't need FL insert, we don't need FL release. We do need FL free though. Oh, FL in it, here we go. Here we go, here we go. I think all we need to do is BS store is equal to, actually, let's do this. Let's just have some fun with this. Obviously, we're gonna need to bump this much sooner, but store capacity is equal to that. Store is equal to malloc BS store capacity and metadata. Metadata is equal to oh, this one's a bit more interesting because we're going to do BSMD capacity times size of BSM. Cool. Probably forgot something. Let's find out what. 20 errors. Nice. All right, what's going on here? BS.h. We have a bunch of. Oh, all right. Okay. Now that we have all this ready, we can do this. Cat source BS. We can just copy this in, and that will give us a good idea of what we actually need to do with the header file. We just basically trim it down, get the includes going. We need BS init. BS init. You can go here, swap this guy out. BS free. That's an easy one. FL, we don't need FL. We do need UINT30, this whole fucking thing. That's an important one. Okay. And BS get. And another BS free. Why is there two of them? No, there's only one. All right, cool. This looks pretty good. Go ahead and compile now for me, would you? What the hell? I guess we're calling each other recursively. That's good. All right, let's BS included multiple times, probably because we forgot the most important thing, which is the if not defined stuff. If not defined, we'll include BS header. Define, and end if. Okay, that's an easy one. Okay. Do this real quick. There we go. Make test. Make test, damn it. BS, undeclared identifier on line 21. What do we got? Oh, right, of course. Of course. BS type BS is equal to malloc size of BS. There we go. New struct. There. Make test. No member called MD start. How sad. Actually, we can just put the header in this side. Close out a few guys real quick. Okay. You want MD start? Fair enough. UINT32 type MD start. Should it be this? Should be a 32-bit. Honestly, I'm leaning towards 16-bit. I am. If we have an error, we have an error. No end, of course not. There wouldn't be. No MD capacity. Yeah, these all have to be the same type. UINT32 type. Store can be that. And we'll also do UINT32. This is going to be a void star. Store itself. And metadata itself is going to be a type BSM star metadata. And let me group these two together real quick. All right, unidentified BSM. We definitely have BSM somewhere, do we not? Did I remove it? All right, let's see how many errors we get. All right, still too many. BSM metadata. Okay, we'll make a new one then. Type def struct BSM blob store metadata BSM. What we're gonna do is that. Cool, different errors. Non-void function does not return a value. Okay, what do you want? What do we need again? Ref counts, UINT 32 refs. I think that should fix that first error. bs.c31 does not return. Okay, let's go back here. Go to 31. What's going on here? Does not return. Oh, of course, silly of me. It's a top error. Let's just go through all these real quick. No member called capacity instruct BS. There wouldn't be. 47. We are talking here about metadata capacity. Okay. 52 capacity. Again, same thing. BSMD capacity. 61 looks for a that. 93 is looking for a this is a struct. My bad. Oh, because we dereference it when we use the pointer. Is that it? Or is this a? Am I doing this? Wait, what is metadata? BSM metadata. Okay, I guess we dereference it into a struct. Fair enough. Non-void cannot return. Oh, actually, we completely forgot to modify the address holder in a few places. Non-void. Oh. Actually, the return value is going to be this. What is this case? If we have 0, so this is the start case. We can just do MDN, which is 0, which looks like an error, but it's not. Return BS reserved, that's going to be handled elsewhere. Put it after last. This one's going to be pretty simple. It's going to be BS, return, is it MD end? Yes. I think most of them are going to be MD end. Okay, so this is the case where we can just put it after last, no need to double anything. If we have, this is the case where we need to double because there's no room before or after. This is the case where we need to, same thing, let's put it after 0, but it's gonna, the end is gonna be kind of looping around. This is just a number. We basically need the index of metadata. Oh, wait a minute. Oh shit, okay, no. We need to do it before we double, so UINT 16 type results is equal to BS MD, and this is a value, so we can just do this, results. Then we do the mod thing, and then we can do that. Okay, so we actually need to do this before we modify MD end, and then we can just do return results. Okay. Same thing here. Again, I know we need a helper, but whatever. Turn results. All right, and I think we need one more place. Return 0. I mean, this is going to be 1. and that's gonna be 0, like, whatever. All right, that fixes a few things. Let's see. Okay, no member called offset in struct BSM. That's an easy one. Offset is going to be an offset into a into store, which is uint32, so that'll be that. And then we also need the last one, which is uint32 type size, and that should fix a bunch of things. Still too many errors. Okay, fine. F error limit is equal to 100. That doesn't do anything. It would not. Okay. Try again. Okay, here we go. Initializing with the expression of incompatible type. Oh, okay. I guess we just need to do this. And now everywhere we use first, we actually need to do 7s first dot. No. Yes. Yes. No. Yes. Same thing for last. 6s last dot. Do we want to copy this little struct here? Shouldn't we just keep it as a pointer? I have no idea. Okay. Was it 108? That should solve a bunch of things because we had that thing, we had that error a lot. Let's try this. Still too many errors, okay. Okay, 126, we have the same thing, struct versus pointer. This is gonna look like metadata. Once we get the metadata, we can just do that. And same thing right there. Right, okay, 186. Oh, we have this everywhere. Okay. Some of these need to be 2s dot. Where else? 141. This one. This one. This one. This one. This one. Okay, we're down to 13 errors, which is pretty good. That last one looks pretty easy. Let's take care of it. BSMD capacity. What are we doing here? What is going? Wait, BS get. Did I forget something here? First of all, four warnings, 9 errors, 4 warnings, 7 errors. 214. Yeah, I don't know what to do here. What is going on? If we decrement and it's the first one, then we march forward until we hit one that's not 0. I don't know. Yeah, we march forward. But if we hit the end, definitely want to break. Definitely want to break out of this because we're going to be reading garbage data otherwise. Good. I think it's a little catch there. Okay, these look scarier. Oh wait, no, they're not. 140. Oh, same thing. Dot refs. 129, same thing. We got metadata dot size. Wait, why is so weird? I mean, these are rare cases. If we need a double, we did something wrong. Okay, down to only one error. Nice. Okay. But they're pretty scary warnings. Okay, 206. What's going on here? If BS MD star is equal to -1 and B, okay, yeah, I know. 83 has an unused expression. Oh, that's a good warning. We would have never been able to fit anything outside of initial capacity. 2 errors and 1 warning. Let's go, baby. This is gonna crash. As soon as we try to build the test, it's not gonna work. We're still only getting, this is just compiling BS. The test is a mess. Okay, let's see. So we have that -1 comparison, which is very valid, very valid. Let me see. No. Okay, how do we shift in such a way that we add 1 afterwards? Oh, we just shift and add 1. Okay, that's an easy one. This will give me, I mean, I can just tell you what it's going to be. If MD start, MD is of type, MD start is going to be of type 16 because we're only going to have we're only going to support 60,000. Jot that down. This only supports 16K snapshots, which may be fine, may be enough. In this case, I can just tell you it's going to be 2 to the power of 16 minus 1. That's that value we're looking for. It's kind of, it is a bit of a magic value, but whatever. Oh, could we use 0 as the magic value? I don't know, maybe. Let's do, can I do, maybe we do it in the header file. How do we do this? What is it, 65535? 65535, I believe. That's like the magic value. I'm just verifying a calculator. 2 power of 16 minus 1. Yeah, 65535 is our magic number. If this ever gets to 0, we got a problem. We got a problem. If we ever double in such a way that we overflow this, then we need to change this whole structure, which will make this take up more memory. How do we do this though? Type def struct order order. Can we do type def? No, it's not a type def. Is it just def? C const. I think it has a system.h. Let me see, any variables here? Define string get text, define, and what is this? That's weird. All right, do we have, oh, here we go. Static const. struct option long ops. What is what the fuck is this? C constant constant values. Let me see how to do that. C constants. Here we go. Oh, you can just add consts. Wait, that's a really. Here we go. Shared C constants. How do we do this? What do we need extern? No, I'm not doing that. We could just do this. I'm just gonna copy them. Just static const int invalid metadata, or we'll call it like initial metadata index. I like that, and it's going to be 65535. I could do 0x something, but I don't know, whatever. To be clear, this is 2 to the power of 16 minus 1, which, yeah, whatever. All right, so in this, we want to find all the negative ones, and we want to swap them out with initial metadata index. Initial metadata index. And we can find all the other negative ones. Okay. Okay. Ooh. We're actually using this quite a bit, which worries me. All right, let's see if that gets rid of that error. Kinda. Implicit conversion from const int to uint16 type changes value. Wait. Implicit. Oh, silly me. Wait a minute. Can we even do this? UI. Oh yeah, this is the max value. uint16 type. There we go. Sorry, I just swapped implicit conversion from int. Do you want me to do this? Okay. Initial metadata index. There you go. Cool. Only one error, and it's a doozy. 89. That's not. Oh, 127. Yeah, I was worried about this one. Passing void to parameter of incompatible type unsigned long. Oh, specifically the last one. Why? Wait, BS. Oh, wait. We don't even. No, this. We just need the size of the block. We don't need the address into the block. I was more worried about this one and this one, because I have no idea if this is even the efficient way to do it. Let's see if this works. Cool. Okay. BS is almost done, but 201. Someone does not return in all control paths. Oh, in this case, what the hell are we going to do here? What is this case exactly? If first dot offset is greater than last dot offset, else if first dot offset is less than or equal to last dot offset. These are opposites, right? So that 151 can just become an else, I believe. So that covers. Okay, let's see. We have return here, return there. Return here, return here, return here. I think that should be good for, okay, cool. All warnings are gone from there. Let me take a quick break. gonna test the shit out of this.